Hi everybody, Tony Lockwood here. We're in Cleveland, Ohio at CAASE 18. Now, I got two smart people here in front of me today, and I want you to introduce yourself and tell us who you are, who do you work for, and what do you guys do?
Thank you. I'll start. My name is Ilona Glatt. I'm a physicist and I work at a software company called Math2Market. And we are developing a software which is suited to study the microstructure of materials. I think we'll probably go into more detail later on, so I'll stop right here and give to my colleague.
Yeah, hello, my name is Constantin Bauer and I'm working also for the Math2Market. I'm a mechanical engineer and I'm responsible for the composite application for the software, Geodict.
Okay, now materials. There's that old movie called The Graduate, and some old guy, such as I, goes up to the college graduate. This is from the 1960s. He goes up to the graduate, puts his arms around him. Let me tell you, plastics. That's where you got to go. Plastics. I think if that was reshot today, they would say composites, right? And tell what are you seeing? What's the action there? There was so much going on in materials.
Yeah, there's definitely a lot going on, and I think the most recent development was the possibility of looking into the microstructure, because the imaging techniques have gotten much better during the past years. So that there was actually the possibility to really look what's going on inside of the material, how it's structured, and if there are any defects that you could actually really see. And with this insight of the microstructure, then it's also possible to alter the microstructure in a way that you would like to have your material to get the properties you want of the material. So it's something pretty new.
It is pretty new, yeah. And now, how do you? Now, for simulation, the users of simulation. Let me take that back. Your users. What are they? What are they asking you for? They really want to get down there and manipulate all the structures, and that sounds rather complex, to say the least.
We're providing a tool
to do
something very complex, but we try to keep the tool as simple as possible so that users can focus on the actual work they want to do.
Yeah.
So it's definitely not easy, but our users are mostly scientists or R&D engineers. Thank you.
Yeah. Thank you.
And they are smart people, so
yeah.
That's definitely something they learn through their studies, and we are giving them a tool to really delve into that experience and topic.
Okay, now, the processing power you require for this, I have a feeling it's not. It requires more than 128K of memory, I'd imagine. Right?
Depends very strongly on what you want to do, but if you have a typical case, you can even do it on your laptop.
No kidding. Yeah.
The CT scanner needs a bigger computer than our simulation tool. So we are importing and running simulations on computer tomography scans. And I think the computer to do so, or the investment for a CT scanner, is much bigger than the software.
Much bigger than the software.
Yeah, we are running our simulations normally on a standard workstation on a laptop. So 8 up to 16 CPUs and 30 gigabyte memory. It's enough. You don't have to go to the cluster.
You don't? Yeah.
No, it's very effective. Yeah.
So I could do it on the airplane on the way home.
Yeah.
Right.
I already did it for my talk to come here.
Yeah. Now, what are your customers asking you for more of? More abilities, anything with it. What are the? I guess that goes to what are the troubles they're facing in the world, not necessarily with your software, but they want your software to help them.
So you're asking which features our customers ask from us which we don't already have?
Yeah, you can put it that way. Yeah, yes, yeah.
Yeah.
It can. I stumped you on that one.
I think one.
Yeah.
I think one thing a simulation engineer has to learn is that currently it's not possible to capture all physics in one model.
Right.
And it's every time the same. You show a modeling and a simulation, and then a few people said, okay, but what is with this effect, and this effect? And I think the first thing is that respecting or regarding the microstructure itself, then you get a feeling what are the most influencing points of your simulation. And it is the microstructure itself and not the small physics effect that we don't capture exactly, okay? So the material properties, I think, in 90% came from the microstructure itself and the material properties. So, and I think therefore our users can get a better understanding of the material, what happens inside, because normally you do on a component level a simulation and get some stresses, but how does the stresses internally affect if you have a composite material or other complex structures? What happens inside and what do I have to do to improve my material to get a better performance on a component level? Mm-hmm. I think that's something our users always need from us, help to understand the material in a better way to improve them.
Yeah, and now, do you leverage material libraries or develop your own, or you just take whatever material they're presenting
There
you?
are different possibilities. We have a library, a material library,
Right.
but the user can also enter its own material properties for the constituent materials,
Right.
for the fibers, for example. And we have some of the materials we also have in our database. Mm-hmm. But it doesn't cover all the materials. I mean, there are always new materials coming up, so it's not possible to cover all of them.
Do you have like a concentration of users in automotive or some of the 3D additive manufacturing users? 'Cause they're crazy about materials at this point.
I think we are serving 4 main business areas. It's the filtration area. Mm-hmm. There are more and more automotive applications for air filters or diesel superparticle filters and so on. Mm-hmm. Then we have the electrochemistry for battery simulation. There's also currently to the electromobility topic, a lot of automotive applications. Then we have the composite field for the mechanics. This is very wide-ranged. Mm-hmm. It's not at all automotive or aeronautics or something like that. It's very wide-ranged. And then we have the oil and gas industry. Mm-hmm. So these are the 4 main industries.
Each confronting different issues too.
Yeah, because geodetic is a very general tool, and that's why we also don't have this big material library, because I think every customer has his own material,
Right,
so we can't provide them all the data.
Yeah, they're going to somebody else, or they have the information.
Yeah.
Very good. Do you provide education, training, that sort of thing?
Yes,
Is it?
I mean, for our customers,
Yes.
we provide a training, and we also provide an introduction when they start using geodetic. So, and we have once a year we have a user meeting which is free for our customers. They can attend that. Mm-hmm. It's over 3 days, and some of our customers, so selected ones, present what they are doing with geodetic and how they do it, and we present what's new in geodetic, and it's a nice gathering.
Do you get into the universities settings or anything like that?
Yes.
As well?
Yes. We have kind of half and half of academic customers and companies, industrial customers. So we are working closely with the universities, especially for new developments of the software. Mm-hmm. And it's also important to us to stay ahead of the research. Not to fall behind.
I imagine. Yeah. All right. Now, why don't you tell us your website, please?
Yeah, it's www.Math2Market.
The number 2.
The number 2, yeah.
Right. Yeah. Yeah. To market.
DE. because we're based in Germany.
Germany, right? Yeah. Yeah. Where are you? Stuttgart? Oh,
Kaiserslautern.
It's near Frankfurt, 1 hour
Near
to
Frankfurt. Yeah. Very good. All right. Well, I will have that web address for everybody. Contact us as the digital engineering editors mail drop. And I want to thank you both very much for your time.
Thank you very
thanks
much
for everything.
you.
And have a great show.
Thanks,
you.
you too.
You too.